Today we are going to look at how glucose meters work. Glucose meters are used daily by people with diabetes mellitus, also commonly known as type 1 diabetes. There are two different types of diabetes, but we will only be looking at type 1. Type 1 diabetes is a disease caused by the body's inability to produce or properly utilize insulin. People are usually diagnosed when they are kids or sometimes in young adulthood, or even older in rare cases. The American Diabetes Association reports that about 20 million people in the U.S. have diabetes, and some people don't even know. And that's about 7% of the U.S. population. Now let's take a closer look at insulin. Insulin is a hormone produced by the pancreas. The pancreas is located between the stomach and the small intestine. The pancreas and insulin are what enable cells to use glucose found in the blood. In diabetes treatment, consists of insulin injections and blood glucose control. Now let's take a closer look at glucose and how we manage that. In order to manage and treat diabetes, people must frequently test their blood glucose levels by pricking their finger. If glucose levels are not properly controlled, it can lead to serious complications short and long term. In the mid-1990s, small electronic glucose sensors were introduced and quickly utilized by diabetics for daily use. By the mid-2000s, worldwide glucose monitoring sales were approximately $5 billion US. Now we're going to take a look at the electrochemistry behind how these glucose meters work. The electrochemistry of the strip is the key to the operation of the glucose sensor. A typical test strip is usually made up of 29% by weight glucose oxidase, which comes from a fungus. 32% by weight is potassium ferrocyanide. And the last bit of the test strips is 39% by weight of non-reactive ingredients. Each test strip has 10 layers, including a stiff plastic base plate and other layers containing chemicals or acting as spacers. One layer contains two silver electrodes, or it can be made by a similar metal. Another layer is immobilized enzymes. The next layer is glucose oxidase. The next one is microcrystalline potassium ferrocyanide. The spacer layers allow a small blood sample to enter the strip. A small blood sample is obtained through a prick of the fingertip, and when touched the tip of the strip, it flows in by capillary action. Then the machine will take a few seconds to determine the concentration of glucose in the blood, and it will be displayed. In the US and Canada, the glucose concentration is reported in milligrams per deciliter, and in Europe it is displayed in millimoles per liter. We will now discuss the chemical reaction of the glucose meter. The first step of this reaction involves the glucose in the blood sample, which reacts with glucose oxidase and forms gluconic acid. The next step takes the gluconic acid, which reacts with ferrocyanide to form ferrocyanide. And the final step uses the electrode. Now the electrode oxidizes the ferrocyanide, and this generates a current. This current generated is directly proportional to the glucose concentration that is displayed. Now we will go into more detail about glucose oxidase. Like I said earlier, glucose oxidase is obtained from a fungus. It is a dimeric protein. It is strongly specific for beta-D glucose, which is the glucose found in blood. Now let's look at the reaction of glucose oxidase. The beta-D glucose plus oxygen reacts to form gluconic acid plus H2O2. This is formed from using glucose oxidase and a phosphate buffer with a pH of around 7.3. Now we will look about potassium ferrocyanide. Systematic name for potassium ferrocyanide is potassium hexacyanoferrate 3. It is also known as red prussiate or Prussian red, and this is due to its ruby red color. It's relatively inexpensive and easily obtainable. It has many different uses as a mild oxidizing agent, and it's also used in photography, blueprinting, and in electroplating, and lastly, it's also used in dyeing wool. In addition to potassium ferrocyanide, other chemicals such as quinone and ferrocene compounds and 2,6-dichloroindophenol have been found to be suitable electron acceptors in this reaction. Thank you for looking about how glucose meters work.